Today we're going to be exploring points, lines, and planes. First, let's look at some definitions. We're going to be looking at space. Space is the set of all points. Point is a location. A line is a series of points that extend in two opposite directions without end. And collinear points are points that lie on the same line. So using these definitions, let's look at some of the first example. I want to know if our points Q, R, and S are collinear. And collinear says they lie on the same line. So if we look at Q, R, and S, they are not in the same line. So no, they are not collinear. Our points P, R, and Q. Yes, they are collinear because all three fall on the same line, which is line G. I want to look at another way to name line G. So if this is our line G, that means it's going through 2 points. We can say we have it going through line P, R. And we can write it with a line on top. So we formed the line PR. Where can point T be placed so that it's not collinear with points Q and S? So if Q and S fall on line H, we can place it anywhere where it doesn't fall on line H. So if I put point T here, it's not collinear with T and S. So anywhere not on line H. Alright, let's look at a couple more definitions. A plane is a flat surface that has no thickness. Coplanar is when points and lines which are on the same plane. So let's start taking a look at example 2. We want to name the plane that represents the front of the cube. So right here we're looking at the front of the cube, and I want to name this plane. So I'm going to do so by picking 4. So I'm going to say it's V, U, Y, Z. You have to make sure you're going in the correct order. You can't cross the plane. So V, U, Y, Z. Let's name it another way. Z, Y, U, V. Those are both different ways you can name this plane. So now we want to name the top of the cube in 3 different ways. So this is our top of our cube. So we have STUV. Name it another way, we can say VSTU. And a third way, let's say TUVS. Alright, now we're going to name a point that is coplanar with T, U, and Y. So here's T, U, and Y. So the 4th point to make that plane is X. So X is coplanar T, U, and Y. It's on the same plane. Let's look at the back side. There's a couple postulates or axiom to define. First postulate 1.1 states that through any 2 points, there is exactly 1 line. So for instance, I have point A and point B. 2 points, there's only 1 line that can be formed between those 2 points. Postulate 1.2 states that if 2 lines intersect, then they intersect in exactly 1 point. So for instance, I have line A and it intersects line B, but it only intersects in 1 place. Postulate 1.3. If 2 planes intersect, then they intersect in exactly 1 line. So let's take a look. For instance, we have our plane here. We have a second plane that's coming down and cutting through that plane. This line right here where they is where they intersect. So then our last postulate is through any 3 non-collinear, so 3 points that are not on the same line, there's exactly 1 plane. So when we take a look, we have 3 points, and we know that these 3 are not on the same line. So these 3 points form 1 plane. So let's take a look at example 3. What is the intersection of plane ABCD? So plane A, B, C, and D, and E, A, C, G. So we have these 2 planes. So we want to know where they intersect, where they touch, and the only place they touch is at A, C. So now we have 2 planes that intersect at GH. So where is that? So here we have GH. We want to know 2 planes that intersect at this. So we have a plane that's on the bottom of our cube. So we have plane G, H, F, and E. And the other plane that uses this is the front of the box, which is G, H, D, C. Now we're going to look at what name the intersection of AC. So here we have AC and GC. So where do these 2 lines intersect? They intersect at this 1 point. It's where they touch. That's at point C. Now we want to name another point that is coplanar with points A, B, and E. So if we have A, B, and E, the only other point that can make that a plane is F. In our last step, we want to shade the plane that contains B, D, and F. So B, D, F, looking at the side of our box.